Hello viewers, welcome to video number 116 of the channel MALACHEMPHILIC, and this video number 116 is the 56th episode of Chemical Thermodynamics. Topic of this episode is Gibbs Duhem equation. So let's start. Gibbs Duhem equation. This equation gives the relation between chemical potential and the amount of the components present in the system. Let's see what is meant by this. See, already I told you for an open system, any extensive property like enthalpy, entropy, free energy, anything is not only the function of temperature and pressure but also the function of number of moles of different component present in the system. That means in the mixture or in the solution. Okay, this already I have told in my earlier videos. Because the open system, they can exchange the matter with the surroundings. So, therefore, any change in the amount or number of moles of any component, with this change, there will be the change in the extensive property. So, any extensive property for the open system is a function of temperature, pressure and also the number of moles of different components present in the system, that we know. So, this Gibbs free energy, which is an extensive property G, that is a function of temperature, pressure, say number of moles of different components N1, N2, say Ni or Nj, etc. etc. Okay. Then taking the total derivative of G, that means total differentiation, then what will be the result? dG will be is equal to dou G by dou T at constant pressure and the constant composition of the components. Say here I am writing, say N1 plus N2 plus dot dot Nj, that is equal to capital N, okay, into dt plus, this I will write separately, plus dou G by dou P at constant temperature and the composition dP plus dou G by dou N1 at constant temperature, pressure and other composition of other components, say N2, all these things, Nj, and J not is equal to 2, okay, because, not is equal to 1, because with respect to one component 1, this change, this indicates with respect to component 1 or number of moles of component 1 or the amount of component 1, what is the change of the Gibbs free energy. So, dN1 plus, say dot dot dot, dou G by dou Ni at constant temperature, pressure, N1, N2 dot dot Nj, and here J naught is equal to I dNi. Okay, fine. Now, see, we know that dG is equal to, already I have derived, V dP plus VdP minus SDT. Okay, this already I have derived. This is for the closed system, means not depending on this composition of the components. So from this equation, del G by del T at constant pressure, that will be is equal to minus S, and your del G by del P at constant temperature, that will be is equal to V. Already we know these things. Okay, I write it, I will make it separate, this one. Okay, so what I can write from this equation? I can write dg is equal to, del G by del T, that is change of G with respect to temperature, that is minus S. So minus S dt, and then this is plus V dP plus these things, del G by del N1, set constant temperature, pressure, and other components, say Nj, and J not is equal to 1 dN1 plus del G by del Ni at constant temperature, pressure, N1, N2 Nj, and J not is equal to I. Okay, so this is the things. Now we know that this del G by del N1 at constant temperature, pressure, and other composition, this is nothing but the chemical potential of the component 1, that is change of Gibbs free energy with respect to the change of the amount or number of moles of the component 1 at constant temperature, pressure, and the composition of other component, that is the chemical potential of the first component, or chemical potential corresponds to component 1. Similarly, this is chemical potential corresponds to component I. So what can I write then? Then I can write it as dg is equal to minus S dt plus V dP plus, here in place of del G by del N1, I can write mu1, that is chemical potential of first component, mu1 dN1 plus mu I dNi plus mu j dNj. We can write it now. At constant temperature and pressure, what is that? dt will be is equal to 0, dp will be is equal to 0, then dg will be is equal to mu1 dN1 plus mu2 dN2 plus, say mu I dNi plus mu j dNj. We can write it. Now, see, when the system has, already I told you earlier, when the system has definite composition, that means, that is, see, N1, N2, Ni, this is the number of moles of components 1, 2, 3, I, etc. Then So then it is the exact function. Then on integration, already this thing I explained in my earlier video, on integration, what can I write? Integration of this equation. See, G will be is equal to mu1 n1 plus mu2 n2 plus dot dot say mu I n I. Okay, say plus mu j n j. Okay, that means G at constant temperature and pressure, this G is equal to summation of mu I or Ni mu I, okay, N1 mu 1 into mu 2 like that, where I is equal to 1 to j. Okay, this is the things, right? So this we got it. So my last equation is G is equal to, I'll write in the next page, G is equal to N1 mu 1 plus N2 mu 2 plus dot dot Ni mu y, say plus Nj mu j. Okay, now taking the, once again I am taking the total derivative of G. Then what it will be? This dg will be, there are two functions. First function differentiation of the second plus second function differentiation of the first, like that formula will apply. So first function differentiation of the second plus second function differentiation of the first, like that we have to write, say plus n2 d mu 2 plus mu 2 dn2, say plus dot dot dot, that is ni d mu I plus mu I dni. Okay, now this is my dg, right? See, here I'll put the equation. Here this dg is equal to, say this is my equation number 1, right? And here this dg, and then see this equation, this is my equation number 2, and this dg, this is equation number 3. Now look at here. Equation number 1 also, what I put equation number 1, that is also dg. dg is equal to these things. And equation number 3 also dg. So comparing equation 1 and 3. Okay, both are equal. Equation 1 also dg, equation 2 also dg. Equation 1 mu 1 d1 dn1 mu 2 dn2. Equation 3 mu 1 dn1 mu 2 dn2 plus what is there, n1 d mu 1 n2 d mu 2. So in place of mu 1 dn1 mu 2 dn2, this part I can write this dg. That means what I want to tell you, then what we will get, mu 1 dn1 plus mu 2 dn2 plus dot dot say mu y dni, that is equal to 0. Okay. So equation 1 is, sorry I wrote wrong. Equation 1 is mu 1 dn1 mu 2 dn2. Equation 3 mu1 dn1 mu2 dn2 is there. In that place I can write dg will get cancelled. So left over will be n1 d mu1, sorry. So left over will be n1 d mu1 plus n2 d mu2 plus dot dot ni d mu I, that will be is equal to 0. Okay. So this one is equal to 0. That means what I can write, this is your Gibbs Duhem equation. So what I can write here, summation of ni then d mu I is equal to 0. Right? So summation of ni d mu I is equal to 0. Now here, if you here this I is equal to say 1 to j, as I have taken. Now here if I divide it by total number of moles of all the components, then what it will be? Then this will be is equal to, say I can write here ni by n d mu I is equal to 0. Ni by n, number of moles divided by total number of moles, that is the mole fraction of the component. So from here I can write that is xi, mole fraction, that is xi d mu I is equal to 0. So Gibbs Duhem equation, these are the two forms. This is one, that is n1 d mu1, n2 d mu2, and another one will be x1 d mu1, x2 d mu2, etc. I'll write here again. So Gibbs Duhem equation, Gibbs Duhem equation, what we got? One is n1 d mu1 plus n2 d mu2 plus dot dot, this is equal to 0, or in terms of mole fraction x1 d mu1 plus x2 d mu2 plus dot 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 is equal to 0. These are the Gibbs Duhem equation. Now let's derive another form. Another form of Gibbs Duhem equation. Let's see. Okay, we'll take the another form. Right. Now let us consider a system of two component. Okay. Let us consider a system of two components. Then what can I write for Gibbs Duhem equation? Either this one or this one. Say I am writing this one in terms of mole fraction. So I can write x1 d mu1 plus x2 d mu2, only two components, is equal to 0. Right? Fine. Now this one I can write like this, d mu1 by 1 by x1, and here I'll divide and multiply by dx1, sorry, dx1, and here dx1. I can write it plus this one, d mu2 divided by 1 by x2. This x2 will go up. Then dx2, and here it is divided by dx2 multiplied by dx2 is equal to 0. Right? Now we know that ddx of log x is equal to 1 by x. So 1 by x dx, that will be d ln x by d log x. Ln means base c. So here I can write d mu 1, this is d ln x. Understood? Ln x or log x, the dx of log x is 1 by x. So 1 by x dx, so d ln x, then dx1 plus d mu 2 by, here also I can write, sorry, this is ln x1, then d ln x2 is equal to 0. Right? Now, x1 and x2 are mole fraction. Right? This is significance of Gibbs Duhem equation. I'll tell you at the end. Okay, x1 and x2 mole fraction. So, total mole fraction will be 1. So, x1 plus x2, that will be is equal to 1. Always that is true. Then, dx1 plus dx2, if I take the derivatives, then it is 0. So, dx2 will be is equal to minus dx1. Right? Here, I forgot to write dx2. Okay. So, in place of this dx2, once again I will write down this equation. This equation once again I am writing, that is d mu 1 by d ln x1 dx1 plus d mu 2 by d ln x2 dx2 is equal to 0. In place of dx2 I will write minus dx1. Then what it will be? D mu 1 by d ln x1 dx1 minus d mu 2 by d ln x2 and dx1 is equal to 0. Now if I take dx1 common, then it will be d mu 1 by d ln x1 minus d mu 2 by d ln x2 dx1 is equal to 0. This indicates that either this term is 0 or dx1 is 0. But dx1 cannot be is equal to 0. Derivative of x1, dx1, this cannot be is equal to 0. So, therefore, what can I write? That is d mu 1 by d ln x1 minus d mu 2 by d ln x2 is equal to 0, and that is for two components. This is another form of Gibbs Duhem equation. This is also another form of Gibbs Duhem equation. Okay. Achha, now I will come to this significance of Gibbs Duhem equation. So, Gibbs Duhem equation just now we have derived, that is n1 d mu 1 plus n2 d mu 2 plus n3 d mu 3, that is equal to 0. For two components, n1 d mu 1 plus n2 d mu 2 is equal to 0, or x1 d mu 1 means mole fraction plus x2 d mu 2 is equal to 0. So, what is indicated by that? It relates the change of this chemical potential, change of d mu with composition. Okay. Now, see, according to this equation, chemical potential is a relative quantity, that is, it does not vary independently but in a related manner. Once again, write down this equation. See, what is the equation? See, n1 d mu 1 plus n2 d mu 2 is equal to 0. Right? So, from here I can write see, N2 d mu 2 is equal to minus N1 d mu 1. So, from here I can write d mu 2 is equal to minus N1 by N2 d mu 1. Look at here. From this equation is important. Look at here. From this equation, you see, if the chemical potential of the second component, okay, increases, or chemical potential of any component increases, then chemical potential of this component will decrease. First component will decrease because this is negative. N1, N2 number of moles, they cannot be negative. So, if this one is positive, then this should be negative. That's why it is written here. According to this equation, chemical potential is a relative quantity, that is, it does not vary independently but related manner. If one is increasing, another one will decrease, and vice versa. Okay. So, from this equation, what can I write? When mu1 increases, that is, d mu 1 is positive, then mu 2 decreases, that is, d mu 2, that will be negative. From this equation we get these things. So if mu 2 increases, mu 1 decreases. If mu 2 decreases, mu 1 increases. So chemical potential corresponds to any component. Here there are two components. A chemical potential corresponds to component 1, does not vary independently. If it varies, then chemical potential corresponds to other component also will vary, and in the inverse way. If one increases, another one will decrease when I am taking the two component system. And from this equation, one more thing you see, if d mu 1, change of chemical potential of one component, is known, and obviously number of moles are known, then d mu 2, that is, change of chemical potential of the second component, can be calculated. So, this is the significance of Gibbs Duhem equation. Hope you have understood. Thank you.